Hello, natural resources. Welcome back. Today we are going to look at some more of the water habitats that animals live in. But we are going to look specifically at saltwater versus looking at freshwater. Believe it or not, even though I have lived in the western part of the state for about 20 years, I am an eastern coastal girl at heart. I grew up about 45 minutes as the crow flies from the beach. And so, whenever I was a kid, if we wanted to take a day vacation or just a drive somewhere, we would get up early in the morning, pack things up, go to the beach. My sisters and I would play in the sand and in the beach, and my daddy would surf, would fish in the surf. He wouldn't surf, but he would fish in the surf. And so for me, growing up with natural resources types things, a lot of what I remember as a child revolves around the ocean. And actually, my favorite time to be at the ocean is not necessarily at summer when everybody's there vacationing and it's crowded. I prefer to be there at night while people are fishing on the pier, or during cold weather because it's not as crowded. So I really do appreciate the ocean for the ocean itself and not necessarily just the vacation portion where people are out on the beach and it's super crowded. Um, there are different zones of the ocean, as just like there was of ponds and lakes. And there's a lot of different ways that they can be classified. If you go to the beach, you probably notice that the ocean is ever changing, because you have tides that are coming in and out. And of course, those tides are affected by the different phases of the moon and the pull of the moon, which seems weird. And it's always seemed strange to me that the moon would affect how our water flows in the ocean. But there are different zones as far as the ocean itself. The different zones are listed on this slide. Super tidal is going to be above water level, above high tide, and below the vegetation line. And so I have a chart that's going to be on the next slide that will help to explain this. You have intertidal, that's the area between low tide and high tide, and that can make a huge difference. At low tide, you're looking at the water being way out on the beach itself and having much more sand and much more beach. Whereas with high tide, you have much less beach and it's coming in toward the dunes. Noretic starts at the waterline and goes to about 660 feet of depth, which is where most of your um, animals and wildlife that like to be in those warmer waters are going to be, especially in the summertime. The warmer waters are actually going to be a little bit further out in the wintertime, but in the summertime, you're going to be looking at this is going to be the area where a lot of it's going to be your lots of life, lots of areas. Bathial, I think that's how that's pronounced, is known as the midnight zone. This is where the continental slope is going to be. This goes from where it is going to be fairly shallow to very steep and deeper in a very rapid descent. And then abysmal, and we really don't even know what all happens in this particular portion of the ocean because we are still discovering new things in this part of the ocean. So this one is still a bit of a mystery because it is so deep and so dark, and literally abysmal. Here is a diagram of the different zones, and you can see how when we're up here on the beach, it is very shallow. Even though it may be over the top of our head sometimes as we get out here, it is going to be very shallow as far as where you actually are in the ocean and how much water there actually is. That drop off, that continental slope, is just really, really a fast drop off, and so as you're getting into some of these other areas, you get down here into this part right down here, you really don't know what's going on in the ocean because it is just so dark. And so there are a lot of things that are actually going on in a lot of different sections of the ocean. And really, all we ever really know a whole lot about is this area right here. When we start getting down into some of these areas, it's just so much more unknown than what we actually can see where we are as far as the ocean itself. Again, I mentioned this already, but gravity and the moon and the sun and the earth and how all that stuff works is actually what creates tides. And these things actually occur at regular intervals, whereas our days are basically 12 hours and 12 hours. We have an AM that's 12 hours and a PM that's 12 hours, and so we have a 24-hour day. You're really looking at tides having a cycle that's 12 hours and 25 minutes. And so that's why the tide is slightly different as far as the time each day. High tide and low tide are going to happen at a slightly different time each day. And so that's why you do see different times of the year, the tides being higher and lower based on um, what time of the year you're actually at the beach. And so the tides are going to be basically 50 minutes longer than our regular day. So that's why they have different times during the day. When the sun and the moon line up with Earth, you've got a strong tide that is going to be produced. This is called a spring tide. When you have them at a right angle, which is what you're actually seeing here in the picture. The sun and the moon are going to be at a right angle from one another. Then we actually have what's called a neap tide, which is a very, very low tide. So it kind of just depends on what's going on with the sun and the moon, whether or not you have a lot of sand to walk on at the beach or a little bit of sand to walk on at the beach. And so really it is all very seasonal, much like we think about our weather being seasonal. Tides and water are also seasonal as well. As you get out into some of the deeper waters, you do have water movements called currents, and these are going to be caused, the surface currents are going to be caused by winds. These deep currents, these bottom currents, are going to be in deep water, and they're going to be, you know, not necessarily caused by winds because they're actually, too deep for the wind to reach. But you have all different kinds of currents that are actually happening. The turbidity currents are going to be caused by earthquakes and hurricanes. As I am filming this video, we are out of school because of hurricane, which became tropical storm Zeta. And so that, we are still churning up things in the ocean, even as far late as the end of October and early November. So we do have a very active current system that's happening with our oceans right now. So right now we have these turbidity currents that are happening. There is even an additional tropical disturbance that's out there that they're saying could go into a tropical storm later this week or next week. So, even into November, we're looking at the possibility of tropical storms and hurricanes. And so a lot of it has to do with these currents and movements that are actually in the water. And you can see on this diagram, there are lots of them, and they're moving in different directions. And so very, very active hurricane season for us, and a lot of that has to do with the current and the way that things are actually moving. One word that you may hear when you're thinking about or when you're around the ocean is estuary. And basically, this picture right here is showing you an estuary. And this is where a freshwater source is going to empty into the ocean. All rivers that are east of the Eastern Continental Divide up in the mountains are going to flow into the ocean. So all of the rivers that are here in Cleveland County, because we are east of the Continental Divide, are going to flow into the ocean. But pretty much anything that is west of, say, the Asheville area, is going to flow into the Mississippi River, which is then going to flow into the Gulf of Mexico. So, anywhere that you actually see these fresh waters, rivers, streams that are going to flow into the ocean, where you've got fresh water mixing with salt water, that's called an estuary. Normally, it's pretty shallow, it's pretty turbulent because you have that water that's moving into the ocean water. There is going to be lots of dissolved oxygen in that water because the water's moving. And anytime that you have water moving, there's a lot of oxygen in the water, which is not necessarily a bad thing. This causes those areas to be really, really nutrient rich as far as different types of fish and things like that. So estuaries can actually be kind of a treasure whenever we're looking at different types of water, because you do have nutrient rich, oxygen rich water that's flowing, and the rivers are meeting the ocean in those particular areas. The bacteria is high because of this amount of oxygen that's there, which causes rapid decomposition of organic waste, which means that the water is fairly clean. It doesn't, it's not a stagnant type of water. And a lot of the marine fish that are harvested actually come from these estuary systems, just because it's a nutrient rich area where there's it's ripe for the fish to be able to spawn and grow to maturity there. So estuary is extremely important to our coastal climate and coastal ecosystem, and where you're going to see a lot of saltwater fish. On the next page, you're going to be looking at some saltwater species. We'll do this very similar to what we did last time, where you will look at the slides, and there will be some ocean videos to kind of help you learn a little bit more about some of these saltwater species. But I will not insult your intelligence by reading slides to you as far as identification. However, we will again have some Kahoots where we are doing some identification of saltwater species, just to see what you know and see what you have learned from the slides. So make sure that you check those out, and I will talk to you again very soon.